So what we're like to do now is talk about the types of crosses, and there's many. And so what I'm going to do is give you some terms. This section will pretty much include the types of problems that we're expecting you to be able to do. And again, we'll do some of these through the Zoom meetings that we have starting on our Wednesday or tomorrow. I'm recording this on Tuesday, but depending on when you watch it, I suppose. So let's talk about the types of crosses. We'll start with monohybrid crosses. A monohybrid cross is a single trait. So that flower color purple versus white, that is a single trait. So that would be what we call a monohybrid cross. A dihybrid cross is actually two traits. And we're going to show you how to do that. Punnett square for that would look a bit bigger. So a monohybrid cross typically is 4 squares. A dihybrid is 16 squares. And then a trihybrid, we're going to have you do one if you want for extra credit. And that trihybrid is typically 3 traits, and that would be actually a box of 64. So quite a bit bigger. But for the test, you will be only expected to do monohybrid and dihybrid crosses. All right, moving along. Some other different terms we're going to need you to know. There is what we call complete dominance, where the dominant phenotype is always fully expressed and hides the recessive trait. That would be the flower color purple. Actually, all 3 of them that we showed you on the peas, the flower color, the pea color, and the pea shape. Those are all complete dominance, where the dominant trait hides the recessive. We're going to show you an example of incomplete dominance. This is seen in a couple of different things. There is a flower out there called snapdragons that come in 3 colors specifically, and that shows incomplete dominance. And they're actually in birds. There is a budgie. Those are also found, or cockatiels do it, I guess, too, I think. They do it. There's several different colors, 3 colors for that. And that's called incomplete dominance. And that's when the dominant trait does not completely mask the recessive trait. And so what you end up with is maybe a flower that is red. That's the dominant color in snapdragons. White is the recessive color. But it turns out when they have a heterozygote, that color is different than either of those. That actually comes out as pink. And so that would be an example. And you can see that in the bottom left there. And so incomplete dominance. And this is not blending. It's not, the traits are very specific. Because if it was blending, that you just kind of get you pour these into a glass and it mixes and it becomes a lighter color, that would then assume that all the children would be that lighter color, the pink, and that's not the case. You will get those true breeding colors back, and we'll show you how that works. So incomplete dominance, and on a test, I will always tell you whether it's complete or incomplete. I don't expect you to memorize all the different types of incomplete dominance. Then codominance is another idea, and we're going to give you an example of that with blood types. If, in other words, you have A blood and B blood, the ABO type blood typing. So here's what I want you to realize with codominance. If you have the A gene, you will have A type blood. And if you have the B gene, you'll have B type blood. And if you have both, you have AB blood. And those are both being fully expressed. So we will show you an example of that also. All right. And then there are some other ideas. We're going to show you how to do a sex-linked characteristic. And sex-linked actually means that it is on the X chromosome, typically on the part of the X chromosome that is missing from the Y. So you can see when you draw this here, there's a little piece right here that the Y does not have. That would be sex-linked. So that means that you would inherit that from your mother. What it really means is your father does not have that to give. And so here's what I want you to think about. We're going to talk about the XY system mostly, not mostly, all. But there are other systems in other animals. Is the XO system, where females and the males, there actually is not another chromosome there. There is the ZW system, where the male actually matches almost like an XX, and then there's a different types of chromosome in chickens. And then the haplodiploid system, where the females are all diploid and the males are always haploid. And there's very few males. Most of the bee population is female, and there's a caste system. So I just want to make sure you understand there's multiple systems out there, but the one we're gonna key into is the XY system. So we'll do a sample problem of this later. All right, and to give you an idea of some of the X chromosome types, color blindness is an example of a sex-linked chromosome. And so you can see on the bottom there, I gave you a little puzzle, and depending on your screen, I don't know if you can actually see the numbers. And there are different types of color blindness, by the way. Red, green is the most common. So on the bottom left, you might be seeing the numbers inside the squares is 58, 18 on the top two. The bottom left is actually not a number, it's a letter, and that's the letter E. And then the bottom right, that is 17. So if you're colorblind, you may not be able to see those. It all kind of blends together. Hemophilia is another example, and that is where your blood does not clot, and there's different levels of hemophilia actually. And and then muscular dystrophy, which is a weakening of the muscles. And as I grew up, Jerry Lewis had a marathon, it's not a marathon, a telethon, I guess, telethon all day. They would take over the TV for a day. Once a year, and I remember every channel. It was, as a kid, it was devastating. You had to watch it, I guess. But if you're watching television, and so that's a disease that there's a protein issue, and you lose control of muscles. So these are examples of some of these sex-linked ones, and we'll do one of these problems, and then we'll do ABO blood typing, and this will probably be the hardest. And so the codominance is what we mentioned above, type A and type B. O is actually the recessive trait. And then multiple alleles, a new idea for you, where multiple alleles means there's more than two choices. So in all the ones we've done before, it was large P, small p, something like that. Where here, we're actually going to have it represented a little bit different. There's two dominant traits. So they usually label A as I to large A. That's one allele. I to the large B. That's the second allele. And then a small I, which is the recessive allele. So I to large A is a dominant trait. I to large B is a dominant trait. And then the small I would be a recessive trait. So there are three different versions you can inherit in this. And then what we're going to add to it is put a little twist on it in the problems. We're going to add the RH factor. When you hear your blood is AB positive or AB negative, that positive negative is actually the RH factor. So we're going to actually make this a dihybrid cross with one of the traits being your multiple allele. So that would probably be the hardest problem that you will have to do on our next exam. And we'll show you how to do those again in class during the Zoom. All right, so here are the blood types for the ABO anyway. They don't have the positive negatives on there. And the idea behind this is you can see here are the genotypes. So this would be somebody who's homozygous dominant for A. This is heterozygous for A. And then homozygous for B, heterozygous for B. If you're AB, this is your only possibility of genotypes, both of the dominant traits, homozygous dominant. But technically, they're not exactly the same. So that's a little funky. We might not use that homozygous dominant for this one. Just know that they are dominant for both traits. And then homozygous recessive down here, you would definitely use two small i's. That would give you O. Just to make sure you understand how blood type work, the reason you have to be typed, if you are A type blood, you make antibody B. So basically your body attacks B type blood, antigens on that B type blood. And if you are B type blood, you will make A antigens or antibodies to attack the A antigens. So here's the problem. If you're A or B type blood, you can't be given the other because your body will actually physically attack the blood. If you are AB, you do not make any antibodies, so you can accept either AB or AB. And then if you're O, you make both of the antibodies, which means the only type of blood that you can accept is an O type blood. The other thing that I don't have on there, probably should have put in the picture, is the RH factor. RH actually stands for rhesus. It's taken because it was first recognized in rhesus monkeys, although we have the same thing. And if you are positive, that means that you don't make any antibodies for this. If you are negative, you make positive antibodies. And so if you are positive type blood, you can take positive or negative. But if you are a negative type blood, you can only take negative blood. You cannot take positive blood. So here's what I do want you to know: universal donor versus universal acceptor. Okay, so if you are AB positive blood, that is good news for you if you're in a car accident, because you can accept anything. There is no type of blood they can give you that will cause problems. If you are the universal donor is O negative, that can be given to anybody. If you are O negative blood, you can't accept anything but O negative. Your body will react to anything else. So if you're in a car accident, O negative is probably the worst thing to be because they only have really one option. So again, the universal acceptor is AB positive. The universal donor is O negative because everybody can take that blood. If you ever watch the TV shows when somebody gets rushed in and they don't know the blood types, they'll always say, you'll hear them as things are going on. They'll basically say something like, hang 2 pints of O negative blood and then cross and type match. And what that basically means is hang 2 pints of O negative blood because we don't know what the hell they are, but then figure out what they are. So if we have to give more blood, we can give them the blood that they are. They can, their type of blood is better for you to have that. And so if you are an O negative person and you donate blood, they will start hounding you because they want that, obviously, because it can be given to everybody. I've watched just recently. I saw a TV series, and it was what I like. It's House, which is not real practical, but it's kind of a different show. But they actually, I heard them say cross and hang 2 pints of O negative and cross a type match, and I didn't believe it because the person had been in the hospital for 2 days. So the fact that they were already in the hospital doing tests and stuff, they would already had the blood type. So that was an error done in that show, which probably doesn't matter. It bugs me because I know it. But anyway, the other thing you should know about this is when this becomes extremely important will be pregnancy. Because if there's a problem, if a woman is negative type blood and she has a positive baby, there can be an issue. Now, blood does not go between mom and dad. So I want to make sure you understand this. The kid that's probably under the most risk is not the first child, it's the second. The first child, as long as mom hasn't been exposed and made you don't make antibodies until you're exposed to something. So during a first pregnancy, often if mom has not been exposed to a blood type, then there's not really a problem. But during birth is a very bloody process. Often mom is then exposed to the positive blood from the baby, but baby's already out. So probably not a big deal. But what happens is what's the problem is the second child. And the second child can be a huge problem because mom has these antibodies are these cells waiting to make antibodies all ready to go. So when she gets pregnant a second time, the antibodies can be made and attack the baby. There is a shot you can get called a RhoGAM shot. And pregnant women often give this, especially if their partners are positive. And typically what happens is they give it anyway, regardless. And I want to make sure you understand it's important because it gets missed. My wife, actually, I know our blood types, and she should have got the RhoGAM shot. One of the reasons we changed doctors is they missed it. She came home and I asked her, hey, did you get your RhoGAM shot? And she goes, no. So I sent her back. I said, hey, go ask why. And she went in and the nurse looked at her file and said, oh, yeah, you should have had it. And they gave it to her. But if I had not mentioned it, I'm not sure they would have caught it. And so anyway, so you need to be aware of that. Okay. And with that, we'll stop the share and the recording.